All right, so this video all right, sorry. This video is going over the arrays or list practice quiz number 1. So this is going to be what your AP test looks like, and it's a little bit different. It's more of the pseudocode than, Java code, but with the Java code, you still should understand how to do this stuff and be able to work through and logically think through these problems. All right, so let's do this. So it says the following code segment uses lists to store and update the 7 natural wonders of the world. You got Aurora, Grand Canyon, Great Barrier Reef, Guanabara Bay, Mount Everest, Parkuden, Victoria Falls, and we want to assign what's in position 4 to Komodo and what's in position 6 to the Table Mountain. Okay, so in Java, you know that your index always starts at 0, but for the AP test, it starts at index 1. So we do index 1, 2, 3, 4, 5, 6, and then 7. Okay, so whatever's at position 4, which is this Guanabara Bay or whatever, will now be Komodo. Okay, so that would be Komodo. And what's at position 6 will now be Table Mountain. So all we do is find this. So it would be Aurora, Grand Canyon, Great Barrier, Komodo. Aurora, Grand Canyon, Great Barrier, Komodo, Mount Everest, Table Mountain, and then Victoria Falls. So that's A. If you look at the other ones, where does it get screwed up? Right here. That's not right. That should be Komodo right there. Because 1, 2, 3, 4, it was in this position that we assigned it. It didn't like assign it afterwards. So Mount Everest. So it screwed that up there. Anyway, it's A. You should be able to go through that and look at that. I don't need to go through and explain that further. 2, the code snippet stores. Okay, so stores and updates a list that represents the playing cards in a player's deck. So I don't know, I'm gonna write this out. I'll say 3, 5, 6, 7, 9, Jack, Ace, and these will be in index positions 1, 2, 3, 4, 5, 6, 7. Again, write these out. These are easy points. Write down the index position. So it says display what's at card 4, so that's 7. So the output right there is 7 so far. So I can cross off F, E, and C. Now remove what's at playing card position 1, so that's that. So that gives me 3, 5, sorry, whoops. That gives me 5, 6, 7, 9, Jack, Ace, and nothing's in index 4 right now, okay? So there's nothing there. Okay, so that's done, that's done. Then it says insert into position 4, 8. So we've got 5, 6, 7, 8. 8 gets put in there, then 9 gets shifted over, Jack, and now Ace. Okay, so remove playing card at position 1, so we remove that. So we got 6, 7, 8, 9, Jack, Ace. So that's good. And then at playing card 1, put 3 in. So we got 3, 6, 7, 8, 9, Jack, Ace. So then it says display what's at position 4. So you got 8. So output 7 and 8. So your answer is A. Okay. Again, this is not difficult. try doing this in your head. Good luck. You'll probably miss it, and if you do, then you know you're going to lose precious easy points. Simple layup points like this must be points that you cannot miss. You can miss hard stuff in this class and still do really great on the AP test, but you can't miss simple stuff like this and do well, okay? And if you work through this, put up your index and put it in a table and remove the positions and shift everything over, it shouldn't be very difficult, all right? So 2 is A. 3. A board games website includes a feature for users to list their favorite board games. When the user first starts their list, the website runs the code to create an empty list. The user then inserts and removes items. Okay, so again, this should be the same. This is really easy. So what do? We've got, I'm going to have to start way over here. Well, okay, whatever. Digs it, gets appended. Code names gets appended. Mysterium gets appended. Scrabble gets appended. Catch phrase gets appended, and then lost cities that gets appended. All right, so this is 1, 2, 3, 4, 5, and 6. So there's 6 board games. Okay, so insert into position 2 Carcassonne, and then remove what's in position 4. So right here we have Carcassonne. Okay, so that's now position 2. This is 3. This becomes 4, 5, 6, 7. Okay. Then we remove what's at position 4, which is Mysterium, and here the best way, I guess the easiest. It's kind of messy, but whatever. What happens then? So that's removed, and this is 1, 2, 3, and then this becomes 4, 5, 6. So you should have Dixit, Carcassonne. So you can remove those 3 because Carcassonne's in position 2. Then we have what? Code names. Code names, so you can remove that. And then Scrabble. So your answer's got to be 3 is C because Scrabble's in position 4. Scrabble's in position 4. Mysterium's right here is in 4, and Mysterium no longer exists in the board games. So another easy one, but you got to write it out. 4. Let's see here. Charlotte is writing code to turn sentences into Pig Latin. This is what she has so far. Okay, so if we look at this, notice that, so Pig Latin, you want to take words and form sentences with them. Notice that, so you have sentence at the top here by itself, and it no longer, once it's assigned to blank, it never gets assigned to blank again. The sentence is always assigned to some sort of concatenation, okay? So if we were to do some sort of loop, well, let's read what the code relies on 2 string procedures: a concatenate string 1 and string 2. This returns a single string that combines the provided string together in order. A substring is a string, a start position, and a number of characters. It returns a substring of string starting at the start position of length, number of characters. The first character in the string is at position 1. Okay, a friend points out that she can reduce the complexity of her code by using abstraction. This is going to be something very important that you do when you guys do your projects. A lot of you might want to code like this, but you're going to have to use abstraction to make the code easier. So this is not only a good AP style question, but this is what you're going to have to do in your projects. Charlotte decides to refactor the code to rewrite it so that it produces the same output but is structured better. Which of these is the best refactor of the code? Okay, so if we look at these, you know what, I might have to let's see here. I'm gonna have to scroll down. Okay, so well, I'm gonna have to just go back and forth. So remember what I said, sentence is blanked out, is set to blank before we ever get into any of this stuff. It doesn't do it each time, okay? So if you're looking at these, which ones do sentence equal to blank only one time? Well, A, sentence is equal to blank, and then you got your for each, and then sentence is never set to blank again. D, you got a sentence equal to blank, and then inside here, there's no sentence equal to blank. E, you got a blank before the for each, and then sentence is never a blank again. B and C, you've got your word array, but then you got sentence being blanked for each loop that you go through. So so for each word in words, you would assign sentence to blank. So each time you run through this array, you would blank sentences out. So I know I can cross off B and C. Okay, just by that logic alone. Okay, B and C have sentence blanked out inside the loop, which would be 3 times it blanks it. So B and C can be removed, and now I can go back to my pencil, and we can start analyzing A, B, and E, because we know B and C don't work. All right, so let's see, how do I then go about ooh, wait a second. Another thing that you can look at, display. Does it display the sentence each time you do one of these? No, it displays it at the very end. So A, you display your sentence at the very end outside the loop only once. D, you display the sentence outside the loop only once, never inside the loop. E, you display the sentence inside the loop, so it would display sentence 1, 2, and 3. So E doesn't work. So now we're down to A and D. All right. So notice this is a for each loop. Okay, for each loops don't have index positions, so you guys are going to be taught more about something like that in Java. In Java, when you use a for each loop, there are no index positions, and you can't do it like that. So D is not correct. A is your final answer. It has to be something like that, where you have the word, and then you know, that's the difference here. Same with that. There's that word right there. You could see this in your test, but you wouldn't see this inside a for each loop. You would only see it inside a for loop or a while type loop. Okay, that's actually kind of a hard one. So you know, you're going to have to kind of know your code in order to know that. This is the only one so far that you know you could get screwed up on, but I did do a decent job being able to logically think through how to get rid of B, C, and E, and now you got a 50-50 shot of A and D, you know, and 50-50 is better than, you know, better than nothing. So Let's see here. Next up, 5. The two programs below are both intended to display the total number of excess calories eaten in a day based on a list of calories in each meal. Okay, so we've got our array. We got an array or a list. Okay, this is the same right here. Total calories. We add up our total calories. That's fine. That's fine. So it looks like the only thing is this one would display. Well, I guess that displays after. That displays after. So I guess this is the only code where there's any sort of, you know, difference. This does it each time. This does it afterwards. So if the total calories are greater than 2,000, so you get to here and you'd have 2100. So 2100 is greater than that. So you do 2100 minus 2000, and then you get. Well, no, this would add up 21 and then 24. So that's 2400. That is greater. So 24 minus 2000 is 400, and then we would display it. So this would display 400, okay? This one, you add them up each time and then check. So this would be like 2100, and that'd be 2100 minus 200 is 100. And then it would go back up, and then it would make that 2400. 2400 is greater than 2000, so that'd be 400, and then it'd display 400. So they display the exact same thing. So it says, which of these statements best describes program 1 and 2 display the same output and involve the same number of computations? This part is not true. The number of computations is more here because you do it each time. You run through that if statement each time. Program 1 and 2 display the same output, but program 2 requires more. That's true. That's more computations. You're doing it each time through the loop. 2 display the same, but program 1 requires more. No, that's not true. That's the same thing as A. Program 1 displays the expected output while program 2 displays the output. No. No. So yeah, answer is B. Okay. Again, and this is good programming too, and this is another reason that takes programmers kind of a while to get good at this, is that there's nothing wrong with this code at the top in program 1, and there's nothing wrong with the program 2. It's just program 1 only does the if statement once, where program 2 does it multiple times. Now, that might not mean nothing with a really small program, but imagine if you had an array that had, you know, 1 million different items in it. And now you're having to call this if code 1 million different times. That could create problems, and that would slow down your code. Okay, so your answer for 5 is B. 6, use the following code segment to answer this question. All right, 6. All right, which of the following accurately describes what the example procedure does? So we've got a list that gets passed in. Answer is 0. The length of the list is len, and we start at I is 1. Repeat len times. So if whatever's at I modulus 2 is 0, then we add up the answer. Then we add up I. Okay, I know what we're doing. This is easy. So let's say we had our list, and inside our list we had 2, 3, 5, 6, and 9. Okay. So the length is 1, 2, 3, 4, 5. That's the length. I guess I don't know the length. Length is 5. So this is the length, and it's 5. So we're going to repeat this 5 times. So the length at So we look at what's at position 1. So this is 1, 2, 3, 4. That's the index position. Always put the indexes at the top of your list. So what's at position, so I is 1. What's at position 1 is 2. What's 2? Modulus 2. Okay. 2 modulus 2. How many times does 2 go into 2? It goes in 1 time with a remainder of 0. So that is 0. Okay. So it is equal to 0. So answer so far would be 1. Okay. Then I gets added up. 1 plus 1 is 2. We run through it again. What's at position 2 is 3. What's 3 mod 2? 3 mod 2. 2 goes into 3 1 time with a remainder of 1. So that's 1. Is 1 equal to 0? No. So we skip this if statement and add 1 more. We go back up. Here's 5 in position 3. So what's 5 mod 2? How many times does 2 go into 5? It goes in 2 times with the remainder of 1. Is 1 equal to 0? Nope, so we skip it. We add 1 to I. It becomes 4. What's in position 4 is 6. 6 mod 2. What is that? How many times does 2 go into 6? It goes in 3 times with the remainder of 0. So is 0 equal to 0? Yes. So we add, answer was 1 right here, so 1 plus 1 is now 2. Okay. And we add 1, and then we go to position 5. Then we do 9 mod 2. How many times does 2 go into 9? It goes in 4 times with the remainder of 1. Is 1 equal to 0? Nope, so we skip it. Add 1 becomes 6. We already did our 6 times. So the answer that was returned is 2 right here. So what is this doing? It looks to me like it's adding up all the, or it's not adding up, it's checking to see how many even numbers are in your list. Which of the following accurately describes what the example procedure does? Returns the number of even numbers from the list. Does it return the average of the list? No. Does it return the even values from list? It doesn't return 2 or 6. It's returning the number, so that doesn't work. It returns the number of odd values? Nope. So your answer is D. Okay. We got just a couple more here. I think I can answer both of these right here. So use the following code segment to answer the following questions. So this is position 1, 2, 3, 4, and then 5. Assume the index of the first item in the list is 1, so that's what I did right there. What is the value returned of a list 3 after the code segment? Well, what's in 3? It's 2. So as we go through and traverse through the loop, when we get to whatever's in item 3, it's 2. 2 mod 2. 2 goes into 2 1 time with the remainder of 0. So that would be A. 8, consider the following code segment. What is the output of the program? It starts, we've got 1, 2, 3, 4, and then 5. The index is 0. Okay, so this is confusing because, like, as Java students, we want to go, okay, yeah, this is index 0, where the principles, you know, stuff is kind of stupid and it starts at index position 1. So it's something that you have to memorize. So what's the length? It's 5. So we repeat 5 times. What's at index position 0 up here? Nothing. It's an index out of bounds there. Index out of bounds. Okay. So that's what they're expecting on that, even though it's funky. And is 8 got, yep, D, index out of bounds error. So anyway, the answers are below here. Make sure you guys practice these and understand how each of them works. And this video is done.